Well, George, today's lesson is going to be on linear equations. Do you know what that's about?
I haven't got a clue, I'm afraid.
Well, George, it's called linear because it is to do with straight lines. And so when you are solving a linear equation, you could be finding where two lines meet without even drawing them.
Well, that sounds clever. Is it hard to do?
Well, it's like everything in maths. It needs a bit of patience to understand the rules and lots of practice to make sure you fully understand them.
Well, I'll give it a go, Gus. And I might even surprise myself.
That's the spirit, George. That's the spirit.
Do you know, Gus, that my last maths teacher used to say I was average?
That's a bit mean, isn't it, George?
Is that a joke, Gus?
A very bad one, George, a very bad one. I think I'd better go over to the blackboard and start the lesson. Okay, today we're going to be looking at how to solve linear equations. So the first question to answer really is, what is a linear equation? A linear equation is an equation that can be solved, in fact, by drawing a suitable straight line graph. But we're not going to be looking at the graphical solution of linear equations. We're going to be looking at how to do it algebraically. So what I've done is I've written examples in two columns. One is linear equations of increasing complexity, and the other is non-linear equations. Now, what is the obvious difference between those two sets of equations? Is that a question you can answer, George?
Yes, I think I know. The ones on the left have just got X in them, and the ones on the right have got that thingy on top.
Yes, you're quite right, George. The little number up top that you referred to is called the power of x. And in the second column, we can see that the power of x in the equations I've given you are 2, or in one case 3. The first equation there is a quadratic equation, as is the second one, and the third one is a cubic equation. We won't be looking at those type of equations. What we will be looking at is linear equations, such as the ones in the left-hand column. In each of those cases, what we've got is an x term. It doesn't appear to have a power with it. In fact, when we write x in algebra, it is actually x to the power of 1. But for convenience sake, we leave out the 1. Okay, so we're now going to move on to the different methods now that we will use to solve linear equations. Okay, so let's look at our first example, which is a very simple example. We're going to solve x plus 2 equals 5. So solving the equation means that we're trying to find the value. Let's look at our first example, which is a very simple example. We're going to solve x plus 2 equals 5. So solving the equation means that we're trying to find the value which x has that would satisfy that equation. And satisfying the equation means making the left-hand side equal to the right-hand side. So I need to find an answer for x. X represents a number such that when I add 2 to that number, then it will equal 5. Now, I know a lot of you will be able to just look at that and say exactly what the answer is without any knowledge of algebraic rules at all. But as the equations get more complex, then we do need to understand what rules or steps we're going to take in order to solve it. So, in order to be able to solve it, we need to understand the idea of operations and their inverses. There are 4 basic operations in arithmetic: adding, subtracting, multiplying, and dividing. By inverse, we just mean the opposite operation, but we use the fancy word inverse in maths. So the opposite of adding is subtracting, and vice versa. The inverse of subtracting is adding. The inverse of multiplying is dividing, and the inverse of dividing is multiplying. So what have we got in this equation? Well, we've got a plus 2. Okay, so what we're trying to do is to find x, so we're trying to undo all of the operations that will eventually lead us to the value of x. There's only one operation here, which is add 2, so that's why this one is a very simple equation. So the opposite of adding 2 is taking away 2. Okay. Now, because an equation is like a balance, I mustn't upset that balance. So if I'm going to take away 2 from this side of the equation, then I need to take 2 away from this side of the equation. Now, since 2 take away 2 is 0, then I have undone my plus 2. That just leaves me with x. On the right-hand side, I've got 5 take away 2 is 3. So the answer to my first equation is x equals 3. Okay, now a balance is a good analogy for an equation because the two sides of the balance are equal, or at least they will if they remain equal, then the balance will remain level. Okay, so let's see how we could do these operations with the balance. As you can see on one side of the balance, we have got the x, which is the unknown weight, and then we've got two other boxes there. Those two boxes represent the plus 2 on the left-hand side, of my equation. So one side of the balance has got the unknown weight x and the other two weights, each of which is equal to 1. So on the other side of the balance, I've got the 5 boxes, and that's corresponding to the 5 that I've got on the right-hand side of the equation. So this balance represents the equation x plus 2 on the left equals 5 on the right. Okay, so how do I solve it with the balance? Okay, so what I need to do is to remove the two boxes, the two small boxes, from the left-hand side of the equation. And then I'll be just left with my x. Okay, so I'm going to take that one, remove it, the second one, remove it. But if I remove 2 from that side, my balance is going to be unbalanced and it's going to tip over on the right-hand side because it's going to be heavier. So because I've removed 2 from the left, I need to remove 2 from the right. Now it's balanced. Not only is it balanced, but I've also now found the value of x, because x was the unknown value and it must be equal to 3 because I've now got 3 boxes left on the right-hand side. So I've solved the equation with my balance as well as solving it by using the inverse operation. Okay, so my second example in this session is 2x plus 2 equals 6. I'm going to do it first of all using the algebraic method, and then I'm going to look at it using the balance. So when I look at 2x plus 2, I see two operations happening to x on the left-hand side of that equation. The first operation is the 2x. Now 2x in algebra means 2 times x. After that, I've got the plus 2. And then on the right-hand side of the equation, I've got the 6. Okay, so the first thing I'm going to do is to remove that plus 2. Okay, so the opposite of adding 2 is taking away 2. So I'm going to take away 2 from both sides of my equation. So I'll put a minus 2 there, a minus 2 there. Okay, so what does that leave me with on the left-hand side? Well, the 2 and the minus 2 will cancel each other out, so I'm left with 2x, and then 6 take away 2 will give me 4. Okay, now I look at the next operation. 2x, don't forget, means 2 times x, and the opposite of timesing is dividing. So I want to get rid of that 2 multiplied by x by dividing both sides of the equation by 2. So if I divide 2 by 2 and I divide 4 by 2, 2 divided by 2 will give me 1, and I will just be left with my x, and 4 divided by 2 will give me 2. So applying the algebraic rules, I've ended up with the answer for x as x equals 2. So now I'm going to move across to the balance to see how that works on the balance, and hopefully will give me the same answer. So as you can see on the balance, there are two sides to the balance, as there were two sides to the equation. I've got the 2x here, and then on top of that I've got 2 blocks. So that is representing the 2x plus 2. And then on the right hand side I've got my 1, 2, 3, 4, 5, 6 blocks. So this is my equation. If I want to find out what x is, then I'm going to have to remove these two blocks first, but not just from this side of the balance. I need to remove them from the other side of the balance as well. Okay, so let me just do that. 2 gone from there, 2 gone from there. I've taken away the 2 from both sides. Okay, the next step is to divide by 2. So in order to divide by 2, I will need to divide the 4 blocks on the right hand side by 2. Okay, so I'm going to draw a line across the middle and cut away the top half. Now I'm going to do the same on the left hand side. And unsurprisingly, this produces the same answer as it did by the algebraic method. Okay, so the balanced method, of course, is only a method for solving simple equations, but it does help to represent our solution in a visual way. From now on, though, we will be using the algebraic method. If you feel you understand what we've done so far, then press the pause button now and try this one for yourself. George will be trying it too and will tell me how he got his answer if you wish to check yours. Okay, George, do you want to tell me what you would do to solve this equation?
Well, first I would add 3 to both sides to give me 9x equals 36. And then I would divide by 9 to give me x equals 4.
Well done, George. That's absolutely correct. Okay, so I hope you too got the right answer or know where you made your mistake. If not, try going over the steps again until you feel you understand it better.
Can I just ask a quick question, please, Gus?
Yes, of course, George.
Well, I get the bit about changing plus to minus and multiply to divide, but do you always do the plus and minus first, and why?
Well, George, that is an excellent question, which I'm not going to answer at the moment. This was only an introduction to linear equations, and so that question will be answered in the next lesson. But you've shown so far that you're certainly not average, and even show glimpses of being awesome.
Just glimpses?
Okay, so that's it on a short introduction to linear equations. I hope to see you again. So it's goodbye from me.
It's goodbye from me.